I bought this vintage Victor 670 printing calculator. Now this thing goes back to the late 70s, somewhere in there. Off Facebook for 10 bucks. It was working. I was going to show it as a teardown. When I got it home, it doesn't work. So I guess we have to fix it first. I picked up this Victor 670 calculator for 10 bucks the other day, and well, I was told that it worked, and when I picked it up, it certainly was working, but when I got it home, it don't work. The display is completely dead. Now it does function. If I say 12 plus 20, it says 32. Whoops, where's it? If I say 12 times 12 equals 144. So we know the calculator part is working and it's printing. If I go onto the negative side, say 10 plus 20 minus, it says negative 10 in red. So I know that it works. The printer works. The display is dead. So we need to fix it. This one has a vacuum fluorescent display. So maybe, because the fact that it did work when I saw it tested, I'm thinking there's got to be a bad connection somewhere. Maybe in the filament circuit. I hope that's all it is. I mean, I probably would have bought it even if the display didn't work. I would have just offered less than $10 for it. I would have said, "Oh, it's broken. I'll give you $5 for it." I have no idea what year this one is either. I gotta think that this has got to be either late 60s or early 70s. Does anybody know? Now, if this comes apart, I think this lid has to come off. And I probably got to take the tape out. Oops. It's a big empty box. And here it is with all of its dust. Should blow the dust out of this thing. What have we here? Looks like somebody serviced this before. 500 milliamp fuse. And I think that wire that somebody has jumpered over it is going to take a lot more than 500 milliamps for that to blow. Okay, I got a new slow blow fuse in there, so that should keep this thing safe. The first thing I need to do is to open it up and see what the problem is. So I guess this keyboard comes off somehow. Usually these old calculators are plugged in. There's usually plugs on them, so okay, I board this up. I think there's a plug down here. I'm going to try and undo this plug so I can lift the keyboard off from the rest of the unit. Be careful with these circuit boards because they're very old and ready to break, I'm sure. Okay, there is the keyboard. I go clean this off, dust it off with my air compressor. I guess next the display unplugs. There's another plug here. See if I can get the display to unplug. And finally, this is the main board. Gee, some of these caps sure look pretty old. Here's the main board here. These connections don't look too good. There's a few of them on here that looks like someone's been into this one. The mask, solder mask, has been stripped off a bit. Huh. Some of these ones like on the front here. But the ones I'm interested in are the ones on the back, which connect into the display. And this is, I guess this is the printer at the back here. This is the printer interconnect cable. And the printer plugs in here. So the display itself, if we look on the display, our filament wires go to the two end pins. And they don't look to be too bad. The two end ones here go down to pin 1 and pin 28. They don't look to be too bad, but if we look on this one here, there's pin 28 over here, and this is pin 1, and take a look at that connection right there. That looks like that might be the fault. See that? It's a bit cracked. Looks to be, at least from my angle, it looks to be that there's some cracking going on this one. That don't look too good. I'm going to resolder that entire connector for the display. Yeah, there's some more over here. This one over here also, see, is cracking on some of these pins here. So we'll redo that board, these connectors. Obviously not going to redo the entire board, but I'm going to redo this connector, and then we'll see whether I've got my display back. Because, as I said, it was working. When I went and looked at this last week, this was working. I got it home and plugged it in. I figured I would just do a nice little demo video of this old calculator. And it would just be a demo video, but once I got home with it and plugged it in, it wasn't working. So then it's like, okay, well, I guess I have to fix it. So let's solder down. Redo the plug. Probably wouldn't hurt to redo the printer socket at the back too, because it looks like there's a few of them on there that are questionable. But definitely a couple of the ones on here are like this one right here. You can see the cracking on this one. Love the smell of the old circuit boards. All these old boards had that distinctive, probably not good for you smell, chemicals. But they all had that distinctive smell. The smell of old electronics. Old reliable electronics, I should say. A lot of racket going on here for the last month or so anyway, besides them building a house down at the corner, a big house with an elevator in it and a 400 amp electrical service. But not to be outdone, the guy across the street from him decides he's going to put a swimming pool in. Right, swimming pools. Of all the things that I would not have, a swimming pool is at the top of the list. And a boat is another. You know the difference between a swimming pool and a boat? You know what the difference is? A swimming pool is a hole in the ground you throw money into, and a boat is a hole in the water you throw money into. That's the difference between a pool and a boat. Both of them cost you a small fortune to operate, if you heat it, for example. And I know people that have swimming pools. My sister has a swimming pool. She doesn't use it. Never uses it because You know, kids are grown, so they're not going in the pool anymore, and it just costs too much to heat the thing for the 3 months that we can actually use one here. I have a hot tub that I don't heat. I use it in the summer as a cooling pool if it gets too hot. But even at that, when it gets too hot outside, it gets too hot in the hot tub. It got up to, last year, because it was so hot last summer, my hot tub was up to 111 degrees Fahrenheit just from the sun. So I had to dump water out and put cold water in to get it down to a nice, 85 to 90, which was just nice when we had the hottest days there last summer in our little heat dome that we had, which we set record heats here last summer. Never been that hot before. Okay, those are done. A few others might need to be done on here too. I want to stay away from the processor, but these regulators look okay. I'm curious as to whether that fixed it. We'll just put the board back in. And plug in the display. I say the connections on the display here don't look to be too bad. They all look okay. So let's plug the display back in and plug in the keyboard and give it power and see whether it fixes it. Okay, that goes down like that. 100-volt cap on this one. What's this other one rated at? 220 at 35, 1000 at 35, 47 at 100, and 33 at 50, and whatever this little one over here is, but I think we're okay. I don't think the capacitors are going to be problematic on this. It's got some Sharp chips in here, and some Mitsubishi chips, and the main processors. I don't even know who those are. I kind of recognize the logo here, but I just forget who it was.
Was it Rockwell? I think it was Rockwell.
Could have been custom, for that matter. I'm sure it was custom. They're probably making their own silicon like a lot of the calculator manufacturers did back in the day. Okay, keyboard goes in, and it just sits in here and plugs in. Like that. Now I guess I can power this up without even putting the cover on it. We'll see whether the display lights up. Moment of truth. There we go. 12-digit display. It's actually quite bright. It's very bright. Excellent. Printer is working. Check out how this printer operates. Maybe we'll feed some paper into it and I'll show you guys how the printer works before I put it together. So the paper goes in kind of, I guess it goes in like this. Paper sits in like that and it rolls in behind this. Goes in like this. I think. There, okay. Let's take a look at how this thing prints. So I would get it to print. Just print some numbers. And I think there's a button on here for printing. This should print this in red. So we should see the ribbon jump up to print just a random number, which is just 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. See, like that. If we look at the actual rollers here, you'll see that it rotates and each one goes to a specific point and stops, and then it prints. So there'll be solenoids on each, I would think, and I'm not going to take the printer apart, but I think there's probably solenoids on each of these, and there's like a ratchet, and it closes the solenoid when it wants to stop it from turning. Looks that's what it's like. Could be wrong. I wonder if we can see it from below. If I take out the screws, can we see this? How this printer works? So there's a couple screws that hold the printer in place. Looks like this was a fast, serviceable, replaceable part, because there's just two screws that hold it in place, and it should lift out. And there is the printer there. What's on the bottom of this thing? Cool. Maybe unplug it and take a look at it. So here's the printer. As you can see, it has a large electric motor which drives this pulley, or this gear, which in turn turns this other gear, which operates this cam on the other side. And the cam does everything, and what it does is it spins the drum. So as the motor turns, it spins this drum, which has the numbers on it. And as the numbers rotate, they are signaled to stop at a specific place as the others continue to rotate. And then once it gets into a position, makes one rotation, and it knows where it is because there's an optical sensor over here on this side. So as it rotates, it knows the position, and it knows the home position. You see here, this rotates. It knows where everything is as it's rolling the drum. And then the cam pushes the roller up against, which has got the print, the tape, against the ribbon and the drum. See? So now it's rotating, and as it rotates, you can see here, it's got this home position, which is a large opening, so it knows when it's at home, and then it ticks off each of the, what this would be for each individual character as it rotates, so it knows where they are. And then there's going to be, if I were to pull this plate out, we'll probably find that there's a bunch of solenoids in here which are all connected down here, and they are told to turn on, which will stop. It's a brake that stops each. As it does the complete cycle, then it gets to the point where it's going to print, and it hammers it up against the ribbon and then resets, and then advances the paper. That is the printer. Quite the little unit. I'm not going to pull the circuit board out. I don't want to damage this. This is very old, but I mean it's built solid. It's all metal. But pretty cool. Pretty cool technology for, you know, for the year. And I would imagine that this was probably relatively expensive when it was new. See, this is the direction it turns, right? It has an arrow on there. It tells you which direction it spins. And then there'll be solenoids that would engage if it was going to print on the black ribbon or the red ribbon. There'd be solenoids here that would engage either this one or this other one over here, would engage and move the ribbon up and down. I don't know if that was on camera there, but we'll try this again. The motor turns like this direction. This spins the drum and it lifts the ribbon up and then does the printing and then drops the ribbon back down. Anyway, that's the little printer. Hopefully I haven't damaged anything by taking it out to show you guys. I don't know if this cover comes off or not. It probably does. But inside here, I'm going to guess there's a bunch of solenoids. That comes off. Yeah, here's all the solenoids. See, there'll be these little fingers here. These are what's going to flip down and stop. And they're on little springs here. So when it's signaled by the calculator itself, it's going to pull that little pin in, which is going to stop this from turning. I don't want to do any damage, so I'm going to put it back together. If it'll go back together. Maybe it won't go back together now. I may have wrecked it. I think this went in under like this. Pretty sure that went in under that, like that, and then this snapped in. There we go. There, that's back together. So I'm going to put this back together before I damage it. I don't want to wreck it. It's kind of cool. I think this old technology, this old stuff, you know, this was cutting edge back in the late 60s or early 70s when this thing came out. Unfortunately, I think I got to pull that display out again just so that I can reseat this. I don't want to damage that ribbon, so let's just pull the board back out. Pull the display out, reset it, reset the printer. Okay, that out of the way for now. Love the modular design. So this would have been built like this so that a business that was using one of these calculators, if they had a problem with it, they would call the serviceman over, and the serviceman would come over and he'd come in with his toolbox, and he would have a new printer in his toolbox or new display or whatever was required, and he would just pop it in right in the office. Because this would have been a business machine, it would have been expensive, and it would have been run by, you know, owned by companies that had a requirement for such a unit. Although not just big businesses had them. There we go. Yep, printing. Yep, working. I remember the TV shop that I worked at there for all those years, the boss had one. So they were pretty popular back in the day. Anyway, let me put the top on it now, and we'll give it a final test once I got it together. How's that for easy assembly? And machine screws that go right into, instead of being screwed into plastic, they would actually went into metal inserts in the plastic. There it is, all back together. Before I close off, I'll show you guys the operation of this thing, because it's a little different than what modern calculators do. The way that you add and subtract on these is a little bit different. So adding is say pretty straightforward. Got a big plus button, and it also has a floating decimal point. Where did that little button tab go? There it is. It also has a floating or fixed decimal point. So, for example, if you're dealing with money, you could put it down in the 2 range, and then everything was in dollars and cents. So if you wanted to, you know, add something up, if you were adding up your receipts for the day, you know, $1.95, $6.49, right? You could add everything up, and it stopped you. It would round it off to 2 points, I believe. And then when you totaled it together, it would round it down to 2 decimal points. So if you were entering more, it would round it down or round it up. But it was fixed at 2 decimal points. Right, and just add up. Hit the total key. It would print your total out. To subtract, it was always the plus key first. So if it was clear, start over. And if you hit this number key, it would print your total on a score line in red. So to subtract on this, you always hit the plus key first. So say you wanted to start out with 150. I'll go back to floating point so we don't have to deal with the two decimals. So say you had 150 and you wanted to subtract 60 from it. You'd hit 150 plus, and then you'd hit 60, and you hit the minus button. They'll give you your total here, right? And it tells you on the tape that you subtracted 60. It's in red. It's giving you a running total 90. If you wanted to add another 30 back to that, 30 plus right? Our total is now 120, right? And then we're going to subtract 90. When we hit the star key, this is the little indicator that it's accumulating register. It would give us our total, our final total, 30. Multiplying and dividing was a little bit different. And I'm not quite sure how it was done on this. I know you just have separate keys over here, but you ended up using these keys. So if you wanted to say 4 times 5, 4 times 5, 20, and you want to divide that by 2. It has memory on it as well, which it's got a total, like a total memory, memory plus memory minus memory total. Yeah, it takes a little bit of thinking on this, but I'm going to just do something quite simple, just to give you an idea how different than this is than modern calculators. 12 times 10 equals 120, plus 24, it's 144. Let's add 2 to it. Plus 2, right, 146. I want to divide that by 12. So I have 146 divided by 12 equals 12.1666667, which I believe is correct. As I say, it's a little different doing this than it is on a more modern calculator where you could just enter the numbers. So you have to kind of think, because you have to treat it as an adding machine, and the multiplying and dividing is different. CA is clear all, and this is your clear and clear error. So you have to start out clearing everything because the accumulation register will keep adding. Let's try another one. So let's say 12, so clearing at 12, times 12 is 144, and now I want to subtract 36, so I hit plus 36 minus, I'm now at 108, then I want to add 24, so I go back and I add 24 to that and hit plus, I'm at 132, and I'm going to want to divide that by 11. So I have to total it first, and then hit divide by 11, and then hit equals, and my total is 12. So the operation of these old beasts was a little different than the modern calculator. Some of the other keys on here, such as N, that's your total number. So say for example, you're adding a bunch of things up, and you need to know, without having to look at the tape, see if you made a mistake. So say you're going to add 7 things together. So 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. Okay, total's 28. Now if I want to clear my accumulation, I would hit the star key. I just wanted to print out my total. It tells me this key here will print the total, but the accumulator is still going. So if I wanted to subtract 20 from that, 20, okay, now I'm down to 8. That would print out 8 positive. I'm going to subtract, say, another 20 from there. Okay, now negative 12. When you're all done and you want to clear the register, whoops, I made a mistake there. But if I hit N, it will print the total number that of operations. So if I clear it, I'll do that again. 1 plus 2 plus 3 plus... Right, there's 7 operations. If I subtract 10, that's operation number 8. If I subtract 17, that's operation number 9. Right, and then if I total it, okay, if I print this up, it'll tell me that there's been 9 transactions, and that will give me my final total. It'll tell me there was 9, and when I clear it, this goes back to 0. So if I did 3 plus 3 and then I hit the N key to tell me that there was a total of 1 addition. If I did 2 additions, 1 plus 1 plus 1, right? That's now there's 3 additions. That's just a running total, so that you can keep track while you're adding things up. Memory works a little bit different on this one. Again, you've got your total and your accumulated total. So if I want to put stuff into memory, say to 12 plus 13. Okay, if I press this key here, it will tell me my total is 25, but it's still in memory. If I subtract 20 from that, memory minus, tell me I've got 5, right? And when I press this key here, that will print out my total and erase the memory. So you can operate, of course, the memory, if you press all clear, like even if I put something in the memory, if I press the clear everything button, it'll wipe the memory as well. So this clear key does not wipe the memory, this one does. It's a neat old machine. You can do basic mathematical calculations on one of these things very quickly, much faster than a little pocket calculator. But neat old machine. Anyway, I think that's probably about all I need to show you on this one here. And oh, it's got a percentage key on it as well. So if you're calculating out tax, say, right? This was good for if you're in a business and you got to add 12%. See, with our stupid tax system, you'd have to do 2 separate taxes on a system like this. Say you had $10. We have 2 taxes, a 5% and a 7%. So you're $10, and you need to add your taxes. So you could go your $10 times 7%, right? Store that in memory, and then go back to your $10 times your provincial tax, right? Add, and then total. And there's your 2 taxes, which will now show. So if you're using one of these to give somebody a receipt, for example, you got your 70 cents GST and your 50 cents PST and your total. So poor man's cash register for giving someone a receipt with a printout. Anyway, neat old machine. For $10, I couldn't go wrong. And now it works. Thanks for watching.